The next topic, again, as I was saying, was the next topic is k-nearest neighbors regressors. And what we talked earlier was k-nearest neighbor classifiers, and the algorithm k-nearest neighbor, actually what it is doing is it's just calculating the distance between and finding the closest neighbor. And based on the closest neighbor, however many neighbors you want, 5 or 3 or 1 or 15, whatever number of neighbors you want, it will make a prediction based on the closest neighbors. For a regressor, and this is a classification, this was a classification algorithm because we were trying to predict if you survived versus if you didn't survive. For a classification algorithm, the output is a categorical variable or a categorical feature. The target is a categorical feature. For a regressor, the target is a continuous feature. It's a numeric continuous feature. So whenever you have to predict a continuous feature, a continuous number, a continuous value, you want to use a regressor for that. So going back to this Titanic example, when we were looking at it, age. So if I scroll down here and if I look at the Titanic data set, and if I do t.info to check how many missing values do we have, we see that age has quite a few missing values. Age has, if you wanted to be very sure that how many is it missing, so you can actually go t.isNull, and then you can actually go sum. And this will tell you how many. So in age, you are missing 177 values. So since you are missing 177 values out of 891, it's almost 20% of the data is missing in age. So if 20% of your data is missing in age, we can fill the missing values based on mean or median or mode, but that's a lot of values being filled in by mean or median or mode. And when you look at the data will lose its shape. So I'm actually going to import this library, import matplotlib.pyplot for some graphing. I'm going to import it as PLT. And I spelled pyplot wrong. Pyplot. PLT, and then if I do a histogram, so t.age.histogram, if I build a histogram for age, you can see that the histogram looks like this. Let me increase the number of bins a little bit so that the graph is a little bit more, more kind of representative. So this is how it's going to look like when I have 50 bins. So this is how the graph looks like. And the maximum value here is 50. And then the graph looks like this with 50 bins. Now, age we know has 177 missing values. So if I fill in the missing values, so if I do fill NA, and the data does not look like, it's not very normally distributed. So because it is not normally distributed, I want to fill it in with the median and not the mean. And again, we could have used mean if it was more normally distributed, but the data doesn't look like normally distributed. So we are going to use the median. So I'm going to say t.age.median, fill the values with this. So fill NA with this. And then I'm going to say in place so that it changes the data set, and I'm going to say in place is equal to true. So when we run this, now if we check t.isNull.sum, now age has no missing values because we have filled in all the values with this median value. Again, we analyzed it, the graph did not look like normally distributed, so we said that, okay, we are not going to use the mean, we are going to use the median, and we did it with the median. Now let me build this histogram again now, because now we have filled in values, We just want to make sure that the two histograms, they look similar to each other. Maybe not exactly the same, but similar to each other. So now if you look at this histogram, now this has spiked very high and its 200 plus values are this value. And if you look at this value, this is about 28. And the reason I know that this is 28 is because the median for age was 28. And because it was 28, it filled all the values with 28, and now you have a big spike at that 28. So filling it in with the median probably is not the best idea when you have 20% of your data missing and you are filling in 20% of your data with median. So I am actually going to go back and import the data set again. And the reason is because I've already filled it in and I want to now show you guys how to fill it in a different way. So I'm going to read the Titanic data set again, scrolling down back to where we were earlier. And now if I do is null sum for age, it should be 177 missing. So we have 177. So we have gone back to our original situation. Now for us to fill this missing values in, we can use k-nearest neighbors as an algorithm to fill this age in. And how do we do that? Is first of all, we are going to take this data set and we are going to separate where the age is missing and where the age is not missing. So let's separate the two. So I am actually going to say that t dot age dot is null. Give me all those where age is null. And this is the data set that I get for where age is null, and it's 177 rows, and this is exactly 177 rows that we were missing. So this is the data set that has age missing. So I am actually going to call this missing, and I'm going to call the other one filled. I'm going to call it filled, and I'm going to say t dot age not null. And we run these two. We just have to make sure that the data that we got is the correct data. So I'm going to say missing dot shape. And I also want to check in the shape for filled dot shape. So you can see 177 for missing. So we know 177. And when we check the info, age had 714 filled in values. And if I go in here, again, age has 700. So the filled has 714 rows. Now, if you look at the missing data set, it has all the features that we had. So it has all the features, the passenger ID to embarked, it has all the features. And similarly, if you look at filled would also have all the features. So we are not dropping any features right now. What we did was, based on where the age was missing, we separated them out. Now we have a missing data set and we have a filled data set. What we are going to do is, now we are going to separate the two independent and dependent features. And we are going to say that based on how much you paid fare, and based on which class you were traveling, and based on your gender, we are going to take these three features as our independent features. So sex, passenger class, and fare. So we are going to define, as we defined earlier, we are going to define here that this is, we are going to use the filled because that has the actual age. So filled data set, and we are going to say that we are going to use fare as one of the features to predict age. We are going to use P class as the second feature, and the third feature we are going to use as sex. And just if you want to look at the independent features, these are now your three independent features. Now this is male and female. I don't want male and female, so I am actually going to copy my code from here. The lambda function that I wrote, where is the lambda? Oh, I can write it again. It'll be easier to write it again. Look for it. So we are going to write this lambda function. We are going to say x, and I'm going to name the feature again. I will call it sex, and we are going to say sex is equal to, I'm going to say from x, just map over, just take the column sex, map over it. So kind of a for loop, and then we are going to write a lambda, and we are going to say take the value of the sex and put it in this x, and make it 0 if x equal male. And then else you make it 1. So if the value of x, which is coming from sex, is male, make it 0, otherwise 1. And now let's run it, and you can see that all of these have been changed into 0 and 1. So this is our independent features. Our dependent feature, y in this case, is going to be from the filled data frame, is going to be age, because in this filled data frame we have age for everybody. Age is not missing at all. So this is going to become our training data set. So this is the y that we have. And then what we are going to do is we are going to take another feature which we are going to call z, and in this z we are going to take the missing data set, and from the missing data set we are going to use the same 3 features that we had here: fair, p class, and sex. And this is our z data set. Okay, need to spell missing properly. This is our z data set, and again z is very similar to how we have the x data set, where we have the independent features. This is the independent features for missing, and what we need to find out is basically we need to predict on the age, and the age predictions are what we are going to calculate for this. So this is the data set that we are going to predict on, the z data set. Now we are going to use the k-nearest neighbor algorithm. So we already have imported the k-nearest classifier, but we need for this, because age is a numeric feature, which is a float, it's a continuous feature. So we need regressor for that. So again, we go to the machine learning library, sklearn, go to neighbors, and then we are going to import k neighbors, not classifier, but k neighbors regressor, because we need in this case a output which is a continuous number. So we're going to import k nearest regressors, and then we can call this algorithm k regressor, kr, we can call it kr, k regressor, k nearest neighbor regressor, and we instantiate the class. So k neighbor, not classifier but regressor, and this is the instantiation of the class. Now we train the algorithm, and when we are training the algorithm, we are going to use the filled data set. So the independent features for filled are called x, and the dependent feature is called y. So we are going to use in this training, we are going to use x and y. So our independent features are lowercase x, and our dependent feature is lowercase y, and this will train the algorithm on that. Now, it is a good idea to actually divide this into training and testing, but again, you can do it. I am not going to worry about this. kind of train the algorithm on all of it. Next step is I want to predict on that new or where it was missing. Also on the missing data set, I want to predict the age now. So when I use this missing data set, that is going to predict the age for me. So once the algorithm is trained and I have a model, I am going to use that model KR and I'm going to do predict. And in this case, I am actually going to put the data set Z because Z was the missing, and I have these three features that I want to predict age from. And then when I run this, oh, I did not convert this male into female. So we have to write this lambda function again for this also. This time it is right here. So let's copy this out. Where is Z? Do this piece. Now in this case, the data set is called Z. And so we are going to say Z and then Z here. And then we run it. So all of these are converted into 0 and 1. And then I make the prediction on this. And this is the age that I got for each and every of those missing values. I can actually put them into Z underscore age. And this, I save them in that Z underscore age variable. Now I made predictions on the age. What I'm going to do is I am actually going to add a new column to this data set missing data set. So let's go back down here. Let's look at the missing data set. Missing data set. So missing data set, if you look at the missing data set, you can see age is all null. I'm going to add another column and I'm going to call it Z age or predicted age. And then we will see how that looks like. So this is missing data frame. And I'm going to say predicted age is equal to, and then it's just Z age. And now I am going to look at missing and it should have a new column here, predicted age. And you can see all the ages are now filled in. And this was filled in using fair, sex, and P class. And based on that, we have filled this age in. Now, we actually do not need this age column. So we can drop this age column or rewrite it on top of this age column. So instead of calling it a new column, I can actually say that I want to call this as age. So instead of calling it a new column, I am going to call this age. Let me just take this here. I am going to call this column age. And after this, I run the missing again. And you can see that all of the age is now filled in. I don't need this spread age now, so we can drop the pred age. And I'm going to say missing dot drop, and I'm going to say pred age, and then axis is equal to 1, and I want to make it permanent, so I am going to say in place is equal to true. And after that, we look at the missing. And now you have all the age filled in. Now, you can actually concatenate the two data frames together. So I can actually say that DF, which is the new data frame, is actually from pandas, concatenate. And what are we going to concatenate? We are going to concatenate the filled data set, and we are going to concatenate the filled data set, comma, the missing data set. And now when you look at the DF, your DF has 891 rows, exactly how we had earlier. We had the exact same number of rows. Looks like age is filled in for all of them. Let's look at DF dot is null dot sum. You see age is filled in for all of them. Now, just to compare, we are going to build a histogram for this. So we are going to say df dot age dot hist and bins is equal to 50. And now this is the let's take this, let's move it up a little bit closer to the other graphs. So you can see that this was the original. This is what we filled it in, which created this big spike. But if you look at this and the original, so let's move it one more further up. So this and the original look quite similar. They are not exactly the same, but they have very similar shape because we have used a different algorithm to actually fill that in. It is definitely much more better than this. There is no big spike. The big number here, or the highest frequency here, was a little bit above 50. Here the highest frequency is still less than 60, a little bit higher, but still less than 60. So we can see that this is a much better way of filling the values based on a regressor, where we used k-nearest neighbor regressor to fill in a value for age. And in this case, age was a continuous feature, so that's why we used k-nearest neighbor regressor to fill that value in.